industrial projects and research work. He has been an actively participated member of NBA, NAC, UGC, and AICTE visits. His main highlights are he has worked with DRDO, Center for Artificial Intelligence and Robotics, Defense Research and Development Organization as an external expert member under the Ministry of Defense Government of India project, SIQ project. He has 5 patents, one from India granted from as international from USA, and 3 from national India patented filed in India. He has 67 international peer-reviewed journal papers, including 24 SCI papers and 43 Scopus and SCIE papers. He has 53 national peer-reviewed papers in his credit. He has total number of paper published in high impact journal, 120 papers in international and national both. He has provided guidance to PhD guidance to 3 students at present. He has guided MTech students, 31 MTech students and 3 MTech students. This is also in continuation. Uh, I'm very privileged. Yes, he is in a member of American Indian Council of Architects and Engineers. He has been a member of American Indian Science and Engineering Society. He has been a member of International Council on System Engineering. He has been a member of International Society of Automation, Indian Society for Technical Education, Institute of Industrial and System Engineering, Society of Manufacturing Engineers, Society of Automotive Engineers, Siemens Product Lifecycle Management. He has been a member of Microsoft certification as well. He has been a reviewer of robotics and autonomous system elsewhere SCI journals. He has been a reviewer of Advanced Robotics, Taylor and Francis Limited, Intelligent Service Robotics, Pinger, Hedberg, SCI Journal, International Journal of Humanoid Robotics, World Scientific Publication Company Private Limited, elsewhere SCI Journal, International Journal of Robotics and Automation Actopus, elsewhere SCI Journals. He has been working as an associate professor and head department of mechatronics engineering in Quantum University, Roorkee. Since July 2019, he has been in the administration part of academics working with Quantum University Center of Excellence Advanced Robotic Control Center, Roorkee as a head ARC from July 2019. He has been working as an associate professor and MTech coordinator in Ambalika Institute of Management and Technology, Lucknow since 2014. He has been worked as an assistant professor in Ajay Kumar Garg Engineering College, Ghaziabad since 2012. He has been worked as a lecturer in Ajay Kumar Garg Engineering College, Ghaziabad since 2007. He has been a member of Academic Council, Examination Committee, Admission Committee, Screening Committee, College Department Council, Technical Training Committee, Research and Development Committee, etc. He has been a PhD in Mechanical Engineering from Annamalai University, Chidambaram, Tamil Nadu. He has been MTech from in Automation and Robotics from Ajay Kumar Garg Engineering College. He has various projects in his credit, like PhD thesis in artificial intelligence control and boot path planning of multi-point mobile robots using hybrid in at techniques. Sir, it's my honor to welcome you. Over to you, sir.
Thank you, ma'am.
Thank you so
So,
much, sir.
good morning to all.
Good morning, sir. Good morning, sir.
So, my topic is industrial robotics. And before I start, I will introduce the basic concept of the industrial robotics and the humanoid robotics. Okay. So this is my core content. 50% is based on the presentation and 50% is based on the practical exposure in different simulators and tools. So the first slide is robotics. Industrial robotics is as an introductory part of industrial robotics. It is a multidisciplinary system engineering related to the class 6 to class 10 plus 2 standard and many more. We have realized that there is a wide gap between academics and expectation of modern industry from the passing out students. Ever changing and ever evolving, technology is virtually transforming every aspect of human existence. This change is constantly creating a need for skilled engineers, managers, and technocrats. India is a rapidly adopting robotics in industrial production. Robotics is a high-end technology stream witnessing rapid development and is being deployed extensively in industrial production, creating a large employment potential for the robotics trained and certified engineers. And industrial robot is a robot system used for manufacturing, especially for the different assembly purpose and the different segments. The most commonly used for the robot configurations are articulated robot and SCARA robot. In the context of general robotics, most type of robots would fall into the category of robotic arm or like as a manipulator. Some robots are programmed to faithfully carry out specific action over and over again without variation and with a high degree of accuracy. So as per the standard definition, the robot is a reprogrammable, multifunction and manipulator. Okay. So if I'm talking about the industrial robotics, so two different categories available in the robotics. One is a humanoid segment and second is an industrial cadre. So industrial robot and humanoid robot programming, operating and integration is an art. And it is based on knowledge, the know-how to designing, applying and using robots in a human endeavor. Robotic system consists of not just a robot, but also other devices and systems and used together with the robots. Robot may be used in manufacturing environments, in underwater and space exploration for adding the disabled or even for fun. In any capacity, robot can be useful, but they need to be a program and control. Industrial robot and humanoid robot can in many situations increase productivity, increased safety environments, increase efficiency, quality, and consistency of the product. And the types of industrial robot. This is a simple example of industrial robots. So categorize the different categories. So 5 different categories available in the industrial robot. One is a Cartesian category. Second is cylindrical, then spherical, and next is a SCARA, and last and the most advanced is the articulated robot. We'll discuss in simulation mode. And this is a simple example. I already discussed about this. Is a simple example of industrial robot. So an industrial robot is an automatically controlled, reprogrammable and multi-purpose manipulator programming in 3 or more than 3 axes. So it's a maximum number of axes is 7 or 8. And industrial robots are much more flexible as to the orientation of the object on which they are operating or even the task that has to be performed on the object itself. As the robot may even need to identify. For example, for more precise guidance, robot often contain a machine vision system acting as their visual sensors linked to the powerful computers or controllers. Artificial intelligence and machine learning is becoming an increasingly important factor in the modern industrial robot. This is an example of humanoid robot. A human robot is a robot with its overall appearance based on that of a human body. Human robots are now used as a research tool in a several scientific area. And researchers study the human body structure and behavior to build human robots, humanoid robots. On the other side, the attempt to simulate the human body leads to better understanding of it. Human cognition is a field of study which is focused on how human learns from the sensory information in order to acquire perceptual and the motor skills. This knowledge is used to develop computational model of human behavior, and it has been improving over time. Besides the research, humanoid robots are being developed to perform a human task like personal assistance, through which they should be able to assist and sick and elderly, dirty or dangerous job. Humanoid are also suitable for critical operations such as robot-controlled mobile or military robots, space research, and automotive manufacturing line worker. The first industrial robot. Unimate was the first industrial robot which works on a General Motor assembly line at the Inland Fisher Bride plant in England Township, New Jersey. And it was invented by George Devil in 1954. In 1960, Devil personally sold the first Unimate robot, which was shipped in 1961 to General Motors. Unimation was the world's first robotic company, and it was founded in 1962 by Joseph F. Engel Burden and George Devil. It was located in Turnberg, USA. So this is our first industrial robot. The first 6-axis industrial robot. Puma was the first 6-axis industrial robot worldwide. The Puma full form is Programmable Universal Machine for Assembly, or the second name is Programmable Universal Manipulation Arm. Both names are correct, and was developed by Victor Shanman at Unimation in 1978. Initially, it was developed for General Motors. This is a real industrial robot. So before I start this slide, I start one questionnaire because session will be interactive. So my question is for the all: a robot is. What is the correct answer?
D. Reprogrammer, multifunctional and manipulator.
Second option, sir. Reprogrammable, multifunctional, and manipulator.
Good.
I think the option is A, reprogrammable multi.
And mathematical? No. The right answer is B. B option is correct. Reprogrammable, multifunctional, and manipulator. Okay.
The option is 4.
So
That
the
is
correct answer is
reprogrammable, multifunctional, and okay, second.
but correct answer is second. I will discuss in last slide. So we'll start and continue. So if I'm talking about real industrial robot, in this side, the three most important parts of the real industrial robot. First is a robotic arm or robotic manipulator. Second is an industrial controller. And third is a KCP or HMI. We will discuss all the part of the next slide in detail. Six-axis industrial robot. So this is called industrial robot or industrial manipulator or industrial robotic arm. And different industrial robot manufacturer offer a comprehensive range of industrial robots and range starting from 3 kg to 1300 kg payloads. So industrial robots come with powerful control technologies, and you can operate your robot and production system simply and efficiently. As per figure, first 3 axes are primary axis and last 3 axes are the secondary axis. industrial robot parts. Industrial robot parts, arm can vary in size and shape. The industrial robot's arm is the part of position at the end effector. Industrial robot body structured parts are the base frame, rotating column, link arm, and wrist. And here you will see the counterbalancing system. Counterbalancing system is basically maintain the CZ of the robot. So counterbalancing is a weight or force that balance or offset another as one when two objects of the equal weight, power or influence are acting opposing to each other, and this device is controlled by automatic root process with the help of AI and ML, means artificial intelligence and machine learning both. And this is the word advanced robot controller. This is the industrial controller generation 4. This industrial robot controller is basically the brain of the industrial robotic arm and allow the parts of the robot to operate together. It works as a computer and allow the robot to also be connected to other system. The robotic arm controller runs as a set of instruction written in the code, and this called as a program. This program is inputted with the teach pendant or HMI or KCP. Many of today industrial robotic arm use an interface with the reassemble or inbuilt on the Windows operating system. The industrial robot control system emphasizes is more powerful, more intelligent, safer, and more flexible than previous models. And it is basically the 4th generation industrial controller. So it is very safe and very high accurate. It emphasizes safety and functionality with the integration of the safety control system. Additionally, there are a huge cost reduction for the integration, maintenance, and servicing of the industrial control, because this is the very advanced and communication mode is available in the 4th generation control, like power pack, servo, electronic measuring device, and communication control units. And this is also supported with the artificial intelligence and machine learning technology. Human machine interface or HMI. HMI, before I start HMI, next question is the real industrial robot part is. What is the correct answer?
A.
Okay.
Option A.
Anyone else?
Sir, option is C.
Option C. Okay. Good. Very good. Or koi?
Sir, I think option B.
Option B.
B.
Okay.
Option B, sir.
D.
Option B, sir. Robot control and HM.
Okay.
Option B, sir. Option B, sir.
And what about C or A or D?
D is correct, no? B.
I already discussed in last line. Just within last 5 minutes, already discussed.
So the option is C.
C. Okay. So the correct answer is B. B is the correct answer because the 3 most important part is the robot or industrial manipulator or industrial arm, and second is a controller because the controller is the brain, and second is a HMI, human machine interface, or KCP or teach pendant. So answer B is the correct answer. Drive is basically related for the motion control. So like just as a servo drive and all. So correct answer is B. Thank you. So HMI, it is very easy to use and user friendly because this is a very advanced and this is a basically smart bed. This HMI is a 4th generation HMI and is a just like as your touch phone. And maximum industrial robot manufacturer offers a fresh approach to robotic teach pendant technology. A number of hardware and software enhancement make product unique. Robot operators will appreciate the smart pad, ergonomic, colorful, and highly interactive design. Plus, the smart pad is not heavy. Its weight just 900 grams to 1100 grams. Commands are easily inputted using multifunctional key, a 60 mouse, and the anti-reflection touch screen. Industrial robot manufacturer had designed the smartphone with more flexibility, allowing keys and a graphical interface to the work to multiple content-driven modes. A hot plug feature allowed the smart pad to be detected from the running robot and system which will not in use. The capability increase overall safety and make it possible to use the same pendant for the multiple work shells. Other hardware features include just like as an integrated USB 2.0 or 3.0 and 2 additional access switches to social for activate 2 additional 8 axis or 7 axis can be controlled through keys. So this is very advanced HMI and this is interact with the between a human and machine or human and robotic arm or controller. So next is a end effector or tool. So this is the most important part in robotic arm. The end effector connect to the robotic arm and functions just like as your hands. These parts come in direct contact with the materials. Some variation of an effector just like as a gripper, as a vacuum pump, as a magnet hand, and a welding torch is based on just application. Suppose welding operations just like as a welding gun, pick and place operation just like as a gripper, and some robots are capable changing end effector with the support of ATC, means automatic tool changer, and can be programmed for the different set of tasks. Like welding, milling, drilling, painting, surface finishing, assembly, it's many more. And next is the robot speed. Even talking about the robot speed, so the maximum industrial robot manufacturer designed the critical algorithm for the finding maximum possible speed. Maximum speed of the robot endpoint is at 2 meters per second. And the minimum speed of the robot endpoint is at 250 mm per second. The robot guides the TCP, the tool center point, along the fastest path to the endpoint. The fastest path is generally not the shortest path and is thus not a straight line. As the motion of the robot axis are rotational, curved path can be executed faster than the straight path. So this is very high tech and this is very, very advanced speed mechanism for the industrial robot. Advanced communication system. As you know, it's a 4th generation industrial controller, and this system is more powerful and more intelligent. And also it is controlled by artificial intelligence and machine learning. In the 4th generation controller, we connect maximum number of inputs 4096 and maximum number of outputs in the 4096. Means at a time we can connect and control maximum 4096 peripherals like tools, like sensors, communicators, etc. Advanced feedback and accuracy. The advanced controller C4 feedback integrate complete robot, motion, sequence, process, and safety control. It is seamlessly incorporates the complete safety controller into the control system. It's a multi-core technology enable the dual channel operations required for the safety applications, just like suppose welding, there's a welding channel operations, milling channel operations. Feedback functions and feedback-oriented communication are implemented on the basis of Ethernet and VxWorks protocol. VxWorks is basically a RTOS operating system, real-time operating system, and it is very advanced for the high-tech communication in real database management. Feedback system and accuracy protocol in VxWorks is very high. And safety and sensitivity are in current market demand. So this operating system is maybe next decade is very demandable. Advanced feedback and accuracy. Basically, this feedback system is inbuilt the 5-layer feedback system and accuracy protocol. And here we use the 5-layer closed loop control system. And closed loop control system are designed to automatically achieve and maintain the desired output conditioned by the panning it or at the actual conditions. Okay. User group. User group is basically define the cadre of the industrial robot programmer. So industrial robot user group contains all the basic, advanced and expert functions such as a path planning, input and output management, programming, controllability and observability. The basic and starting group is user. User group is designed for the just like as a operators. An operator can set up and operate the industrial robot. And next group is the expert group. This group is especially designed for the robot programmer. Robot programmer can provide the technical expertise required for the integration, programming, assistance and service of the robotics app. And the last is the administrator group. Most of us know what an administrator profile as well as a general user profile when it comes to our PC.
Excuse me, sir.
Yeah.
Sir, in the expert program, you have written advanced program using KRL language. What is that language, sir?
KRL is basically a global platform language. This full form is KUKA robotic language. K for KUKA, R for robotic and L for language. KUKA is basically a world top 2 robot manufacturer in the terms of industrial and humanoid robotics, and KUKA is also tied up with the NASA. So KUKA is designed and developed the world finest industrial and humanoid robotics in terms of research, in terms of operations, manipulations, and different critical processes. So this programming language is a global programming language for the different types of the industrial and humanoid robots.
Thank you, sir.
And it is very complex because this is the basically related to real-time operating system, RTOS based programming system, and so VxWorks.
Okay.
So administrator is just likened to just a god, and user are likened just to a general populace. So similarly, as administrator has full access to account with the all permission, including just like as add or remove users, configuration of the robot controller, configuration of the robotic system, robot maintenance, integration, programming, and subscription, etc. Industrial Robot 4.0, because this is a next generation system. So Industrial Robot 4.0 is completely changed the manufacturing environment. Businesses are empowered to make more profitable decision when they have detailed production data at their fingertips. Industrial Robotics 4.0 solutions for the automation integration, increase competitiveness and allow percentage level of productivity. This technology essentially allows for the communication network of connected devices, machines, or different types of real or non-real softwares and pupils. With the help of Industrial Controller 4.0, we can operate maximum 4096 robot at a time with a single controller as a master controller or with the support of host server. And we can control the entire system via your iPhone or iPad and also save the labor cost and time. So this is very advanced and this is next generation technology in industrial cadre. So before I start this slide, term is questions. So what is CCU? Any idea?
The option is C, Communication Control Unit.
Okay.
Yes, sir. C.
Anyone else?
Control your control, sir.
Okay. The right answer is Communication Control Unit.
Sir, A is the correct answer.
Sorry. Correct answer is C. Communication Control Unit. So we're talking about the core area in robotics. There are 6 different core areas available in the field of industrial robotics and humanoid robotics both. So the primary and the basic area is programming. Next, maintenance, integration. Next, artificial intelligence and machine learning, neurology and physiology. 6 different and core area in humanoid robotics and industrial robotics cadre. What can robot do? And this is the based on application. As more and more robots are designed for a specific task, and this method of classification becomes more relevant. For example, many robots are designed for the assembly work, and which may not be readily adopted for the other application, and they turns as an assembly robot. So one especially dedicated robot is designed and developed for the SCARA. So SCARA is basically selective compliance assembly robotic arm. This robot is especially and dedicated for the assembly purpose only. So this application is, this is a welding process. I will give the detail in simulation. Next, this is a, any idea about what is this? Any idea?
A robot, sorry, an industrial robot?
Yes, it's an industrial robot, but the whole system is one technical word. This platform, and this platform.
So it can say pick and place machine.
It is pick and place.
Pick and place machine.
Yes, okay. And actually, this machine is AGV, automatic guided vehicle. Automatic guided vehicle. I will show in video also. So this robot is basically articulated robot, and this is 6-axis industrial manipulator. With the help of AGV, we can move any direction, X, Y, and Z direction, and also any type of application. Suppose we installed here is a pick and place tool, so this robot become as a pick and place robot. Suppose here we installed a welding tool, so this robot is welding robot. So depend on this tool or application or requirement, robot will change or robot will operate different types of processes. So this is basically very advanced machine, and this is a AGV, automatic guided vehicle, without any human support. And next, this simple drilling process. This is a MAPS. MAPS means modular automation production system. So this is basically support the advanced automation work. Suppose in terms of CNC support, DMC support, AMC support. So this type of support is basically the cadre of industrial robot is a MAPS robot or MAPS automation. And this is a medical operated robot or medical research robot. So next is advantages of the industrial robot. So this is a very common advantages, and you are also very well aware. High production requirement, reduce lead time, setup time elimination, better quality with lower price, safety in operations, safety of manpower to service sector, reduce rework processes, competitive productions. And this is the disadvantage of the industrial robot. System changes are difficult and slow to implement. High cost and long-term payback because the industrial robot cost is very high and automation's cost is also very high. And the next is unemployment. This is the most important part. If you're talking about the unemployment, then 4 different categories available in the market. One is a unskilled, second is a semi-skilled, third is a skilled, and fourth is a highly skilled. And here I'm strongly mentioned, if you are in an unskilled and semi-skilled cadre, then immediately change your cadre to skilled technocrat. Otherwise, your smile of unemployment may be in dangerous situation. Because
sir,
if you are, yes.
Me, sir. Sir, can you
Yes.
please repeat the advantages of this?
Sure. So the advantages of industrial robot is basically high production requirement, reduce lead time, means the cycle time. Okay. Setup time elimination means setup process time. Next is a better quality with lower price. If we implement the different types of advanced automation or advanced robotics or all work with the integrated system configuration with the advanced programming. So immediately the quality is upgrade and cost will be definitely when compared with fixed or flexible automation, fixed or programmable automation, then flexible automation will decrease the cost. And the cost is the most important part, because if cost is very high, then product sales and marketing is very tough. The safety in operations, shifting of manpower to service sector, reduce rework processes because the quality is improved, then rejection is going to decrease. Competitive productions. Okay.
So much, sir.
So I think, is it clear? This slide is clear?
Yes, sir. Clear.
Industrial requirement word robot market, and this data is very authenticate. January 2020. If I'm talking about the different type of applications, suppose material handling worldwide 24.4%, welding 16.5%, spray painting and finishing 14.5%, waterjet 12.4%, mechanical assembly 6.2%, electronic assembly 4.8%, material removal 4.5%, inspection and testing 2.9%, SCARA productivity, I already discussed in last slide. SCARA is a supervisory control and data, I miss, actually, I forget the full form. SCARA productivity is 2.7 and other is 11.1%. Okay. Next is a distribution of the world robot population, Jan 2020. So in the terms of ranking, so Japan is number 1, 44.1%, and USA is 22.1%. Germany is 7.8%, and India, if I'm talking about India, so 2.2%. So maybe some improvements is required for the India, and other is 9.6. So business and job opportunities. As you know, industrial robot is a multidisciplinary system engineering related to different branches. So we need engineers, we need technocrats in different segments like electronic and communication segments, computer science, information technology, electronic and communications, and different types of special branches. The revolution will create exciting career opportunity in different industries like manufacturing industries, petroleum, oil and gas industries, building material, construction industries, consumer durables, it's many more, and telecommunication, computer hardware and software industries. So pay structure of the robotic programmer, and this data is basically taken by the authenticated site. This pay structure data is basically taken from the official website of Maruti Suzuki India, Hyundai Motors, Honda Car India, Volkswagen, General Motors, Tesla Motor USA, Volkswagen Motor USA, BMW USA. In India, basic robot programming is from 4 to 8 lakhs, and advanced level 7 to 16. Expert is 19 to infinite. Infinite means is depend upon the industry needs or industry requirements. Your experience, knowledge, multitasker ability is totally depend upon the situation. Similarly as the USA. So if I'm talking about a career in robotics, so definitely it's a bright. The major robotic companies in India, KUKA, Fanuc. KUKA is basically last 3 years #1 company in worldwide. Then Fanuc, ABB, Mitsubishi Electric, Stobli, Kumayu, Kawasaki, Denso, Jo, Yashikawa, Yamaha, Omron, Nachi, Epson, etc. And this is the major automation companies in India. It's like just as a Maruti Suzuki, Hyundai, Isuzu, this is a top major automation companies. And the conclusion. I already talked in presentation about the way of future computing, automation, digital robotics, business and academia, and daily life for the everyone. Purpose of talk is to make people appreciate how the process of automation and robotic computation has become an essential part of all. And that we do use and depend on 24/7 all of the world. So in the terms of industrial automation robotics, Sir Stephen Hawking was in graduate session in October 2015. So he advised that that next decade overall robot will replace humans, and the future trend in industrial automation robotics that overall robots replace the human in next decade, or maybe 10 to 15 years. Major jobs will be created in the terms of robotics, in the terms of automation, AI, machine learning, deep learning, brain and blockchain technology, and industrial cybersecurity as a priority basis in next CAD. Big data analysis become a competitive differentiator. Open automation architecture will be implemented, and virtual solution will be as a definitely implemented. And I think collaborative robots will be continue to grow in popularity because in different types of industrial robotic application, collaborative robots is a major role in industry. So thank you. So The terms is question. Next term is maximum number of inputs and output is
1026.
1026. Good.
4096.
4096.
D option.
Okay.
Option D.
Right answer.
Option B.
Right answer is
Option B, sir.
option D.
Oh,
4096. The maximum number of inputs and maximum number of outputs in terms of external or in terms of internal input generation or external input robots controller is the number of inputs and number of outputs. Maximum is 4096. And the next and last question is SCADA is
Option A. Supervisory control and assembly data acquisition.
Option D.
I think option A.
Option A. Option A.
Are you sure?
Option C. Control and data security.
Correct answer is supervisory control and data acquisition. Option C is the correct answer. Okay, so I will move in practical exposure mode. Before I start practical exposure session, so this is a real industrial plant in Pune, and this is a Volkswagen plant. Volkswagen is basically a car manufacturing company, and the mother company is a Volkswagen. I think Polo and Vento se dekha hoga. So Volkswagen is a mother company, and sister concern company is just the Skoda. Skoda is a Volkswagen company. Audi, Lamborghini, Bentley, and HP. This is basically the associated company, and the mother company is Volkswagen. So this video is a real video in Pune. The robot's maximum speed is 2 meters per second. So this plant is completely automatic, and I think he used the robotic Autos version VX works 4.8.2.
Sir, please
So-
repeat the video, sir.
This is a Volkswagen car plant video. So please here see. And this is a simple example of artificial intelligence and machine learning. This war is human versus machine. So this robot is a KUKA AKR HLS, and this is 6-axis industrial manipulator with the support of real-time operating system. And its controller is 4th generation controller KRC4. This is a simple example of AI and machine learning. So I will start the basic demonstration. This tool is a RoboDK, and this is a free for 30 days. This is a robotic simulation software. So this is the online library. So you go to the online library, or you can save different types of robotic and tools for the offline programming. Just 1 minute. So this is a different types of robot, and the company is ABB, Obo, Adept, NM, Kodak, Kumau. These are different types of companies. So suppose we choose a KUKA. So this is the KUKA robot. Okay. So suppose download a 6-axis or 16 kg payload. So this robot is industrial carrier robot, and this is a 6-axis industrial robot. I already discussed this is a basically 5 different types of category. One is a Cartesian robot, second is a cylindrical, third is a spherical, and then is a SCARA, and most demandable and very high accuracy based is the articulated robot. So this robot is articulated based. So I will show the moment. So when I click this robot, so this window will open, and this is a basically 2 different types of motion movement. One is a translation movement and second is a rotation movement. So what is the effect? What is the difference? I will show you here. So when I select the translation in X direction, then no movement is here. Okay, but translation in rotation, so movement is visible. Okay, so translation movement is basically movement from the one destination to another destination in a axis specific movement. Suppose we have 5 axis or 6 axis industrial manipulator, and we move translation movement according the X, Y or Z axis. So if we choose a translation motion, so we move the different types of the axis or specific axis specific movement. So suppose we choose a Z axis in rotational form. So this is the motion of the A6 axis. Okay. Then this button is a home. This is a home button, and I will show the A6 axis. So A1 is here. So this 6 axis is related to A6 axis. So this first axis is the parameter is basically from maximum and minimum movement is minus 185 degree to plus 185 degree. So this movement is A1 axis movement. Okay, so this is the axis A1. Means if I move the axis specific movement, then move only dedicated axis. So this axis is a axis 1, and this is the moment. Okay, this is the minus 185 degree to plus 185 degree. Got it? Second, A2. A2 is minus 185 plus 65 degree. So this axis is, second axis is here, this portion. First axis is here, second axis is here. So this is the minus 185 and this is the plus 65. Okay. The third axis is here. This is the third axis because first three axes are the primary axis. This is the first, second and third. This first three axis is the primary axis and last three axis is the secondary axis. The first three is a main axis. So this third axis is minus 135 to plus 175. So this is the third axis. Okay. Fourth axis is, to show you. Is it visible? Hello, is it visible?
Yes, sir.
Yes.
Yes, sir. Yes, sir, it is.
Axis 4 is minus 350 degree to plus 350 degree. And axis 4 is this orbit. This block O-ring is called, in technical word in robotics, is orbit. This is O orbit. This is A4 O orbit. And this is a A1 orbit, A2 orbit. This is A1 orbit, A2 orbit, A3 orbit. This is A4 orbit. And this is a A5 orbit. And this is a A6 orbit. Okay. So I'll move fourth axis. So this is a fourth axis. And this range from minus 350 degree to plus 350 degree. Okay. So
Sir, can you please define the orbit?
Orbit is basically,
sir.
Hello, yes. Sir, orbit is basically the axis movement. Here is actually specified the servo drive. Here is a mounted a servo drive. The servo drive is connected with a one communication control channel, and this communication control channel is coordinated with the one O-ring cycle implementer. Actual में the hardware name is cycle instrumenter, and this is called the orbit. And this axis is basically placed on this orbit, this O-ring, this black color O-ring. Got it?
Yes, sir. Thank you, sir.
So this is a A4 axis, and A5 is this axis. Okay, so this axis is minus 130 degree to plus 130. So this is a A5 axis. Clear? And this is a A6. A6 is minus 355 to plus 350. This movement is 355 to plus 350. Okay. So I installed one tool. Already installed different types of tools. Suppose I installed one welding gun. Open. and this is a basically installed A6 axis. So this portion is the end effector of the robot. So from A1 to A6 is a different types of axis. From A1 axis, A2 axis, A3 axis, A1 axis, A2 axis, A3, A4, A5, and the A6 is the end effector of the robot. So when I add any tool or any machine process operation instruments or any type of third party hardware, so it will be integrate with this A6 axis. Okay, and this is basically integrated with hardware, also software. So this is a basically welding gun, and this welding gun is implemented with the robotic system channel. So if I move this axis, so the move is a basically, this is a basically robotic welding and robotic manipulator or industrial robotic welding manipulator. So when I click on robot and when I move the axis A1, then it is moved with the tool. Okay. Clear? Then I will show you one small process. Suppose we use any robotic painting. Yes? Yes, ma'am? Any question? So this is basically a robot, and this tool is basically paint gun. Then this robot is called as a paint gun robot. And this is the object.
Can we download this? Yes, sir. Can we download this program?
Yes, sir. You can download the program. You can download a robot. You can download a tool via this online library. Okay. Suppose you can integrate with the any industrial robot with the industrial controller and the support of the different type of application, welding gun, milling, drilling, circle finishing, any type of tool. So you can download online, sir. So this online download portal is here. So if you click here, so then this is the basically online robot library. Okay. So this thing here.
This robot, actually, sir, robot DK software is also downloadable.
Yes, sir. It is free for 30 days only.
Okay.
Okay, sir. You can purchase for the education purpose also, but this is especially free for only for 30 days.
Oh. Sir, can you share the link of it?
Excuse me, sir.
Sure. I will share a link. So suppose you go to the RoboDK site.
Excuse me, sir.
Yes, ma'am.
Is this software is for designing a robot or to know how the robot has to be?
Ma'am, you can design, develop, integrate, modulate, programming, integration, sensor integrations, input and output hardware integrations, communications, artificial intelligence, machine learning, deep learning, neurology, fuzzy, communication channel integrations, layouting, route implementation. You can create anything, ma'am. This is a very good software actually, and this is free for 30 days just only.
Okay. Thank you, sir.
Okay, ma'am. So this is the basically software of RoboTK set. So you go to the download section. Okay, and this is your as per your standard criteria. This is also available for the iPhone also. So this
So what is the
compulsory.
site?
Sorry.
What is the site to download?
Sir, the site is RoboDK, sir. Sir, I will show you again. I will show you again, sir.
RoboTK.
So just go to the Google and then type RoboDK. Okay, RoboDK. You search on Google, and this site is the official website of the RoboDK. Then click, and this is the official website of the RoboDK. Okay, sir. So you can download here, and different types of resources is here available here. Suppose you can download a tips and tricks or documentation, offline programming. So this is a basically resource panel. So you can download or you get online help. Yeah. Okay,
Thank
sir.
you, sir.
Thank you, sir.
So this is a complete help panel. Okay. So this is a basically industrial paint gun manipulator, and suppose if I run, then see, this is a paint gun operation. Okay, this is a painting operation. Clear? So you can create a robotic system integration or create any type of process, and you can design and develop any type of simulations and check is it verified or not, is it okay or not. And this is
Sir,
also
from which
support.
class we can start this? From which class we can start it?
It's depend upon basically this is for 6 to 12 standard, but I think this is good for 9 to 12 standard actually. So
Okay.
because the Python is here, there is a Python code. This is very good programming. Suppose we integrate the different type of channel, we integrate different type of subroute system. So we need a Python programming, or you can program in C, C++, C has RTOS, VxWorks. So,
Hello,
but
excuse me, sir.
Yes, sir.
Hello, sir. How we can integrate Python to robotics in this programming? How
Sir,
it is helpful, sir?
Sir, the portal is here.
Okay.
My cursor is visible.
Okay. Yeah. Yes, sir.
So this is basically linked for the Python. So suppose you can add here or you can add here. This is the this is the CAD programming, or you can add here. Okay. So this is the link of Python. I will show you.
Okay, sir. Okay, sir.
Okay.
Okay. Thank you, sir.
So I will show you again. If I run the program, main program. Okay. So this is a simple operation of the integral. Clear, sir?
Yes, sir. Sir, excuse me, sir.
Yes, sir.
Yeah, sir. Can you integrate one simple program to integrate with the this robot so that it is very easy to understand? One Python program we can integrate with this robot.
Sir, before Python program, you can add a direct text manipulator and
sir, give some examples so that
sir, VxWorks.
Yeah.
I will show you, sir.
Yeah.
So this is a basically real-time system. Sir, please your mic off, sir.
Please mute yourself, please.
Sir, echoing.
So this is a site, sir, for the VxWorks. This is the operating system, and this is work on the real time. And you can download here, or You can go to download this site. Otherwise, you can go to the Orange Edit site. And then go to download. Okay. So you can download here. So here two version is available, one for the admin version and second is a no admin. Then you can download and integrate with the this RoboTK software. Okay. And after that, I will show you. I have created one small program. Just 1 minute. I will show you the basic code for the. I think, so any idea about C, C++ or Python?
Yes, sir. Yes, sir. Yes, sir. We know C, C++ and Python. Yes.
So this programming is basically related to C++, but C and C++ is basically graphical based integration. C++, and Python, and one database. You can use a Oracle or you can use a SQL database with the help of VxWorks integration. So this is a simple parameter, simple programming for the, and that programming methodology is the RTOS. So this program is critical systematic implementation, and this is specially designed for the artificial intelligence and machine learning based critical systematic implementation and advanced brain routing and control for industrial robot controller KRC code. And this is very basic program. So you're just aware of basic graphical coding related to C and C++, Python, and Java crypto languages. Okay. So just 1 minute. Okay. So this is a program. Okay, आप सिर्फ please confirm me what is the output of this line. Just 1 minute. Just 1 minute. Wait. I will convert it in PDF form because some problem in my Microsoft Word.
Hello.
Sir, I will open the PDF format. here just so this is a code. Is it visible?
Yes, sir.
So this is the basic implementation code and based on the critical systematic implementation. And this program is with the help of C, C++, Python, I think 20 to 30% code in Java and SQL database. Okay, so just tell me what is the output of this line. This line. Call it this. From def that to this frame. What is the output? You can take a screenshot and we will discuss after 10 to 15 minutes. I will move the presentation and simulation side. Okay, just please take this snapshot. I will discuss later. So this is a basically welding operations. And I can take one different example. So suppose we can take a laser cutting. So this is a basically laser cutting operations. So this is a laser cutting machine, and this is also integrated with the KRC4 controller with the support of Python. Okay, and this is the basically this command is operated with the help of CIRC circle command. So circ.ini.root.imp and is equal to the implementation. Suppose in case we choose any inputs and we choose any outputs. So suppose we choose number of inputs is 2 and number of output is 3. So we integrate here this circle or any of the circle. So we can integrate this circle similarly here, similarly here, similarly here. Okay, and this is the basically integrated with the AI and machine learning. So before the programming, we integrate the VxWorks, we integrate the Python, we integrate the one additional is SQL database because database is the most important part of programming. So we integrate any database. Okay, so you can download the SQL from the Microsoft side, or you can download the Oracle from the Oracle side, and you can integrate directly with this Python. Okay, you can integrate first to integrate the Python, then you can integrate with Robotic. Okay, this is immediately entire integration with the one root implemented. Okay, and this is a basically basic input and output generation control system. So this operation is laser cutting. So I will stop this operation and I will give you one different demo. And next is I will show you different operation. So this simulator name is RoboLogics. This is also for free for some days. So I will show the arc welding. Okay. So this is an arc welding operation here. This is a panel. This is a basically HMI. This is a robot and this is a controller, and this is a HMI, means human machine interface. And we can program and create with the help of also we can help over the Python or any SQL database programming, or you can also program with the oriented software. Okay, so I have loaded some examples. So suppose this is a different types of programming. Suppose we can take one example, then we can load here. Okay, and then we can run. So this is basically automatic operation of this operation. So this is a WIB, body in white, and this is a car, any automotive car raw body. This is arc welding. You can integrate with the motor also. This is basically servo motors. You can integrate the different types of sensors, different types of actuators, different types of motion controller, and you can add and connect with the directly or indirectly with RoboDK, or you can connect with this arc welding software. Okay, with the help of any ARTOS operation system. Got it? Then painting. I will show you the painting operation. So I can load any program. So this is a painting gun. And I will the pick and place operation. This is a conveyor, and this is the object. And this is 6-axis industrial manipulator for the pick and place operation. And this is just as a pick and drop. Here we wait 20 seconds. Okay, so this is a pick and place operation. and I will show you one interesting application. And this is for the both industrial and humanoid, both robotic operations. Okay, so this is actually my favorite. So suppose we can choose non-mobile robots. So these are different types of the robot. Suppose we can choose this ABB robot. Okay, and suppose let's start the simulation. Then this is basically the direction control mechanism. So this is a X, Y, and Z direction control mechanism. You can create or you can manipulate the different types of pick and place operations, any type of building operations, or you can manipulate any type of the road system implementation operations. And I will show you one non-mobile. So this is a human robot. Suppose you can program a human robot. You can also program with the motion control mechanism. So you can control here actually. So step size, if you increase step size, walking speed, this is a low walking speed and this is a high walking speed. Okay, so this is a drawback.
Excuse me, sir.
Yes, sir.
Sir, can we generate C code, sir, with this simulation, like a Python or C code?
Yes, you can generate, sir. You can generate two different methodology. One is a pre-processor, second is a post-processor. So suppose you can generate a pre-processor base, then you can convert this programming languages in .psi method, dot RTS method, or VWS method. You can generate any type of program, but you can, if you generate the post-processor method, then you can integrate with the Python integration with the database management system, and then you can program and generate. Okay.
Can't we generate in this tool only, sir? We have to inbuilt one more tool, sir.
No, you can generate. So you can generate. Basically, this is a robotic decade. Is a simulated software. So you can integrate any type of the programming language. But the most capable and most demandable or most preferable software is Python. Okay, and with the support of database. So you can convert, program, and generate, integrate the different type of software like C, C++, or you can generate any type of software, sir. You can integrate any type of software. But the important is the compatibility. Compatibility is the most important part, because the servo drive and servo motor is not compatible with some other software like wave root software or a workspace software. I will show you workspace. Just 1 minute now. I will show you. You can try it, sir. Okay, so this is also based on programming language, and you can try it. and contact me if you have any problem or something. Then you can contact me, sir. Okay. So this is a different types of robots. This is AGV. We'll show you in the slide. We'll ask the question. This is the AGV. So this is a basically obstacle sensors inbuilt in 4 direction, and this is control and observe the different type of operations. Okay. So this is just as a just like as a transportation system mechanism. So this is a, we can place any object from one destination to another destination, and we can create path planning, we can create motion integration, we can create axis direction, different types of control mechanism in this AGV, automatic guided vehicle. Okay. And this is also AGV. So suppose we can move forward. So let's move the forward direction. And this is a rotation control. This is a 6-axis industrial manipulator. We can use any type of operation. Suppose this tool is basically pick and place operation, so you can use as a pick and place operation. Otherwise, if you mount it here as a welding tool, so you can use as a welding tool or welding robot. Okay, and this is a movable item, so you can move different locations, and you can weld different locations without any human efforts. So this is left and right portion, and suppose you can move. I will show you. Suppose you can move axis 2. This is axis 1 and this is axis 2. So suppose you can axis movement, so you can move here. Suppose A1 axis, so you can move axis A1 is here. Okay, and with this help, you can create any type of the robotic system process, or you can create any type of robotic programming with the support of AI or support of ML. Okay. Any question? Yes, sir. हाँ सर, सौरभ अच्छा.
Thank you so much, sir, for such a wonderful session. So now I would like to call Mr. Yogesh, sir, for giving vote of thanks to the sir.
Okay. Dr. Kamlesh Singh, Professor.
Mr. Yogesh sir, please unmute yourself.
Hello.
Yes, sir. Yes, sir. Yes, sir.
Yes, now you are audible.
Dr. Kamlesh, Associate Professor, Quantum University, Roorkee, was Industrial Robotics. Explain the following during his session. Two robot and types of industrial robot. The first robot come in existence in 1952. Real industrial robots and industrial robot controller. Its subtopic was advanced power pack, EMD, ECU, common communication control unit, and human machine interface, HMI, and factor or tools, communication control, advanced accuracy, closed loop control system, and industrial 4.0. Advantages of robotics, industrial requirement robot market January 2020, and major robotics in India, and have given many example of simulation based robot. Now I would like thanks Kamlesh Singh and we present here. Now thanks a lot.
Thank you so much, sir. And thank you so much, Kamlesh sir, for such a wonderful session. And I hope all the participants are getting knowledge from you. So now we are having a 20 minutes break and we're joining after 20 minutes for the next session at 12 p.m. So thank you.